Please find this page in your packet. It should be page 35 and the back side is 36. It's a couple pages past what we did yesterday for homework. So pause this video until you found it. Today we're going to talk about adding integer strategies, and we've actually talked about a few of these. We're going to model with chips or counters. We've modeled with vectors already. We're going to talk about a new strategy with using the highlighters, and you can see that these numbers are larger. And on the back side, we're finally going to talk about the rules. So let's go ahead and start with the number lines. So this was the first thing that we did, the vectors, as they're called. And you're going to notice, hopefully, that we're given a negative number and another negative number. So these are same sign numbers. When we model with vectors, we always start at 0. So I see the first number is -3, so I'm going to go to the left, 1, 2, 3. I'm counting on the number line, but a vector is a line with an arrow pointing in the direction it's going, and it's the length of that from 0 to -3. So this is a model of -3. I'm now adding -5. So I start where I've left off, and I'm going to the left again because the number is -5. So 1, 2, 3, 4, 5. So I'm now going to model my vector. I'm going to put a little starting point for this vector, and my end point is the arrow, and this is a model of -5. The most important part, of course, is that we ended up at -8. Since this is an expression, I would write that answer down below. So if I look at this next example, I'm going to use -3 and +5. So these are different sign numbers. But the process that we do starts the same way. I start at 0. Since it's -3, I go to the left 3. And here is my vector that shows that this is a model of -3. Now here's the difference. I'm still going to start at -3, but because it's a positive number, I'm going to move to the right. 1, 2, 3, 4, 5. And you can see that I've basically undone this movement, which it kind of undoes it. And so my vector would look like this. It would be a +5, and I landed on 2. So hopefully you may have noticed in the past that when I have different signs, I'm really kind of subtracting. And hopefully you noticed that yesterday when we used the chips. So let's go now to the chips or the counters. Let's go to Roman numeral 1. So as I look at my numbers, I'm given a -2 and a -7. So these are same sign integers. And yesterday we learned how to model, and we're going to model our -2 with either a pink or red or closed circles. That's a model of -2. And now I'm going to include a model of -7. And because they're the same sign, I add all these chips or count up all these chips. And the answer, which I'm going to go ahead and make an equation is at this point, equals -9. The color tells me what sign they are, and then the amount is by counting them up because I'm adding. All of them are the same color. I absolutely do not want to zero out when they're the same color. If we go over to our next example, these are different signs. I have a negative and I have a positive. So I'm going to start the same way by modeling my -2 using my red chips. But this time, the 7 is positive, so it's going to be, I'm going to use the color yellow. And again, if you wanted to use your highlighter, that's awesome. Now with this model, I do have opposite signs. So now I need to zero out, which means I'm creating 0 pairs. This is 1 pair, 1 red and 1 yellow. That's a 0 pair. Another red and another yellow. That's another 0 pair. But here's what I have left over. So again, the color tells me that it's positive. And so the number of them, there's 5 positive counters or chips. So that's a strategy we can use. Now you're going to notice that both this example and this example were both smaller numbers. So this might be really cumbersome if I have to draw 34 negative chips or 90 or 78 negative chips. This would not be very efficient. So this is where our next strategy comes in. We're going to move to our highlighter. As you can see, both of these numbers are negative. So I'm going to highlight these numbers in pink, which is our negative color. And just like up here where both of the numbers were negative, we ended up adding their values and keeping the sign. So we already know, or we are going to learn, that when their numbers are negative, we're adding two negative numbers, we're going to keep that sign. And we're simply going to add their absolute values. I'm just not using their signs right now. This is 34 away from 0. This is 78 away from 0. And when I add 4 plus 8, I get 12. 1 plus 3 plus 7 is 11. So this is a negative 112. So this is the answer when I add negative 34 and negative 78. This time, the next problem asked me to model and add a negative 93 and a positive 57. So I'm going to start by modeling, or by highlighting in pink my negative 93, but my 57 I'm going to highlight in yellow, which is my positive color. And just like I did up above, I'm going to end up zeroing out. I'm going to be able to take 57 chips or counters, if I modeled them, away from both sides, and whatever's left over here will be my answer. So another way to look at this is the number that has the most value, the absolute value, the one furthest from 0, that is going to be the sign of the answer. So I know it's going to be leftover negatives. So this is where it gets weird. When I'm working with different signs, instead of adding, I'm actually going to take the highest absolute number with the highest absolute value, and I'm going to subtract the number with the lowest absolute value. So I'm going to have to take or borrow from the 9 because 3 take away 7 I can't do. And I'm going to pretend that's 13. 13 minus 7 is 6. 8 minus 5 leaves me 3. And so there'd be 36 leftover negative chips. So when we do this, opposite signs, or different signs rather, it's a little bit more complicated because what we see is we see addition, but we're really subtracting. So now let's go to those rules. Would you turn to the next page? So when we're dealing with same sign integers, for instance, 2 positives or 2 negatives, the rule is that we're adding, so we add the absolute values of those numbers. We're going to add, that makes sense because it says we're adding, of both of the numbers, and then we keep the shared sign. So let's put this into play. If I have 27 plus 12, I'm going to add their absolute values, and since they're both positive, absolute value stays positive. And so the answer is positive 39. Again, both of these numbers are positive. So if it helped you to highlight them, to point that out, be sure to go ahead and do that. Our next numbers are both negative. So again, because of the same sign, we are going to add their absolute values. So the absolute value of 53, negative 53, would be positive 53. And the absolute value of negative 16 would be positive 16. And we're just going to add those. We're going to get 69. And what this means now is my value is 69. However, they're both negative, so I have to keep the sign, so it's negative. If you recall, too, in case I confused you, the absolute value just means how far is this number away from 0? Well, it's 53 counts. How far is this number away from 0? Well, it's 16 counts. We're basically ignoring the signs until the end when we realize that they're both negative, so the answer is going to be negative. So we're now going to look at adding opposite or different sign numbers. And I'd rather you look at this as different sign numbers instead of opposite sign numbers. So different. And the rule says, and here's a doozy, we actually subtract the absolute values. It seems uncomfortable since we see addition. And then we choose the sign of the number with the greatest absolute value, the one that's furthest from 0. So let's look at how this is. Again, if it helps you to highlight, I'd encourage you to do that. I can see that 49 is positive. I can see that 18 is negative. And so I'm going to look and see which number has the highest absolute value. Well, it's 49. And so I'm going to start with 49 when I start my subtraction. I'm going to start with 49. And since it's the highest absolute value, I know that my answer is going to be a positive. And then I'm going to subtract the number with the lowest absolute value. So 9 minus 8 is 1. 4 minus 1 is 3. And so I'm going to have 31 leftover chips, or counters if you want to think of it that way. So the answer is positive 31. When I look at the next example, I see negative 75, and then I see positive 26. So I can tell that the number with the highest absolute value this time is negative 75. So I'm going to start with its absolute value. I'm going to write 75. And I can tell, that the sign is going to be negative because I'm going to have leftover negatives if I modeled this with counters or chips. So the absolute value of 75 minus the lowest number absolute value, which is 26. So again, 5 minus 6, I'm going to have to borrow. And I'm going to pretend this is 15 minus 6, which is 9. 6 minus 2 is 4. And so I'm going to have 49 leftover negative chips if I modeled this with chips. So I hope that this was helpful. I'm hoping that in the next couple weeks you'll kind of move towards the rules or be able to use the rules. And if not, use those other strategies, particularly the highlighter, that hopefully will help you. Thanks for watching, and would you please go to the exit ticket now.